so let's start the experiment. This is my AES code. It has some UART configuration set up, which does the printing on the terminal. It has timer set up, which takes the timestamp of when the encryption starts, and then it takes the timestamp of uh, when the encryption stops to calculate my time that it took to encrypt the data packets. And then um, I also have 8192 rounds of encryption. Why did I choose 8192 rounds? Because one data block of AES encryption is 128 bits, so 8192 rounds of encryption would simulate uh, 1 megabit of data being encrypted. So let's start the experiment and uh, see what results we get. Right, so as we can see, this is the AES time. Set it to integer. The value would be in microseconds. So now I'm going to run my encryption. Uh, as you can see on the putty terminal, we get an output AES encryption start. And as you can see on the putty terminal, the AES encryption has completed successfully. We get the encrypted ciphertext here, as you can see in the memory view layout, and the encryption time it took was roughly 11 seconds. And the same can be, so if we stop debug session, yes, we can see AES time is again the same, 11 seconds. And now we can also do it without the debugger uh, by just flashing the board. Give it a second. Yes. So we flash the board, and if I press system reset, we should see the progress of the program on the putty terminal. Yep, encryption has started. And the encryption completed. Okay, so now let's try to get the timing measurements on the picoscope. To get the timing measurements on the picoscope, I need to make a small change in the code. So basically, just before the encryption starts, I'm going to set the pin number 30 as the output pin, and I'm going to set it high. And as soon as the encryption ends, I'm going to set that pin low. And then I have the picoscope connected to that pin and ground, and so it's going to read that waveform on the screen, and we are going to use that waveform to get the timing measurement. So here we go. Press system reset. As you can see, the encryption has started. The pin is high. As soon as the pin goes low, the encryption will end. Yep, it has ended. Now we stop this. As you can see, takes 11.03 seconds, which is the same that we got from the timer. So unfortunately my screen recording app has stopped working, so I'm gonna have to record it on my phone. And so let's do the timing measurements for Chacha20. I'll start by starting a debug session. As you can see, this is Chacha time, which will give us how much time it takes for the encryption. And I'm gonna press start. As soon as I press start, the putty terminal showed us encryption started, and yes, the encryption is completed successfully at 5.262 seconds. And as we can see in the debugger, the variable Chacha time also shows 5.262 seconds. Okay, so let's get the timing measurement for the Chacha20 using the picoscope. So I'm gonna start the waveform and I'm gonna press system reset, and as soon as I do that, the code starts executing as we can see on the screen. Since Chacha20 is a much more lightweight encryption algorithm, it completes faster than AES. Stop this, get the rulers. As we can see, the measurement that we get is 5.272, which is very close to the measurement that we got using our timer in the code. And so these are the timing measurements for AES and Chacha20. Now let's go hop on over to our breadboard setup and measure the power consumption for both of these algorithms. This is my setup for measuring the current that is drawn by this board. And so for that, what I've done is I've connected this board in parallel to this 10 ohms resistor, and then I'm gonna use a multimeter to measure the current flowing through this, and that would give me the current that would be flowing through this board. I'll multiply it to the supply voltage of 3.3 volts and multiply that by the time taken for each of the encryption algorithms to get the supply power required for both of these encryptions. So now we're going to record the power drawn by the board when the programs are running. So as we can see on the screen, we get a reading of 0.0. Let's restart the program. Get a reading of 0.065 milliamperes. So the energy consumption of each program would be as follows. Since the supply voltage is 3.3 volts and the current is 0.065 milliamps like we measured, and the time taken for AES is roughly 11 seconds, and for Chacha20 it's 5.262. So since energy is voltage into current drawn into the time taken, the energy required for AES would be 2.377 millijoules, and Chacha20 would be 1.129 millijoules.